In this, our math video tutorial, we will repeat all shortcut multiplication formulas in algebra we already learned in our previous math video tutorials, since these formulas are very important in mathematics. First of all, let's begin with shortcut multiplication formula: x squared minus y squared, which is equal to x minus y times x plus y. To prove this formula, we have to multiply these two brackets. So we first multiply x by x and then x by y. Then we multiply y by x and y by y. We already did it in our previous tutorial, so watch our previous tutorials and you will understand every formula I will repeat in this tutorial. So we will have x squared plus xy minus xy plus, minus y squared. And we will have cancellation here. And after cancellation, it will be equal to x squared minus y squared. Next formula, very famous formula, and we will use this formula very often in our calculations. It's shortcut multiplication formula for x plus y squared. So this is equal to x squared plus 2xy plus y squared. This formula is also very easy to prove. X plus y squared is equal to x plus y times x plus y. So if we perform multiplication, it will be equal to x squared plus xy plus xy plus y squared. And these two xy will be equal to 2xy. So we proved our formula. Another variant of this formula is x minus y squared, not plus but minus. This is equal to x squared minus 2xy plus y squared. To prove this formula, again we have to multiply x minus y by x minus y. It will be x squared minus xy plus y squared. And these two minus xy's give us minus 2xy. So this formula, these two formulas combined can be written as, because since we have here plus and plus, here we have minus and minus, combining these two formulas we can write x plus minus y squared equal to x squared plus minus 2xy plus y squared. Next shortcut multiplication formulas is x plus minus y to the power not 2 but any power n. This is called binomial theorem, or this formula also called binomial of Newton. Binomial of Newton. And to write shortcut multiplication formula for this case, we use Hayam-Pascal triangle. In previous tutorials, I already gave a definition what is Hayam-Pascal triangle and how to construct this triangle and how to use this triangle to write binomial theorem or binomial of Newton. Let's do it again for case when n is equal to 3. In this case, first of all, we have to construct Hayam-Pascal triangle. This is done in this way. So first of all, we write number 1 at the corner of this triangle or this pyramid. Next, we write it in this point. We write the sum of these two elements. It will be 2. At this point, we write the sum of these two elements, which is 3. Here, we also write 3, the sum of these two elements. Here, we write the sum of these two elements, and we will have 4. Here we will have 6, and here we will have 4. This triangle is used to write shortcut multiplication formula for example, x plus minus y to the power 3. And first of all, we write x to the power 3. I am giving you certain rule how to remember this formula. We write x to the power 3. Next, we write x with power less by 1, which is x squared, and write y. Here we had y to the power 0, but we do not write it because this is equal to 1. Next member is x with less power, just x, and y with power 2. And next, here we have y to the power 3, and here we had x to the power 0, but we do not write it. Next, we have here the certain levels of our triangle: level 0, level 1, level 2, level 3, and level 4. Here we use the level 3 because here we have power 3. And we use coefficients 1, 3, 3, and 1. So here we have 1. We do not write it. 3, 3, and 1. And to write the signs, here we have plus. Here we have minus, y minus, because, here we have plus minus. Because if here y is with the sign plus, here we had just y to the power 1, and it will leave sign plus. If we had the sign minus, here we had y with the power, with the sign minus, and it will remain. Whereas here, since we have y to the power 2, so in this case, plus y and minus y will be transformed into plus y squared. So here we will have always plus. And last sign will be again plus and minus, because we have here y to the power 3. And again, let's write it separately. Plus minus y to the power 3 is plus minus y to the power 3. This is obvious because y to the power 3 is equal to y to the power 3, and minus y to the power 3 is equal to minus y to the power 3. So it was binomial theorem for the case when power is equal to 3. Let's write a binomial expansion. It's also called expansion for case when n is equal to 4. And this is done easily. And here we use the line number 4 in our Pascal triangle. So we have x plus minus y to the power 4 is equal to x to the power 4, x to the power 3y, x to the power 2, y to the power 2, x and y to the power 3, and y to the power 4. Next, we use these coefficients. And these coefficients are 1, 4, 6, 4, 1. So we have here 1, 4, 6, 4, 1. And we do not write number 1. Next, we have to write the signs plus or plus minus. Since here we have y with power 1, we write plus minus. And since here we have y with power 2, we will have always plus. Since here we have y to the power 3, we have plus minus. And here, since we have y to the power 4, we have always plus. So it was shortcut multiplication formula or binomial expansion when n is equal to 4. To write next shortcut multiplication formulas, we have to repeat the divisibility of x to the power n plus y to the power n. We have two cases here. Divisibility by x plus y and x minus y. We also had another binomial, x to the power n minus y to the power n. And we had two cases, x plus y and x minus y. In previous tutorials, we already learned that here, for first case, we have divisibility, but n must be odd. Odd numbers are 1, 3, 5, not divisible by number 2. Here, we didn't have a divisibility, and we can prove it using Bezout theorem. Next, case number 3, we have here also divisibility. So x to the power n minus y to the power n is divisible by x plus y. But for number n, which is even number is 2, 4, 6, number must be divisible by 2. And here, last case, we always have divisibility. That's why for first case, we have representation, because of divisibility, x to the power n plus y to the power n is equal to x plus y times some polynomial. And n here must be odd, or it can be represented as some number 2 times some integer number plus 1. Here we have nothing. We have nothing. So in other words, x to the power n plus y to the power n cannot be represented as x minus y times some polynomial. In this case, when n is even, we also have a representation x to the power n minus y to the power n. For n which is even, or can be represented as 2 times some integer number k, is equal to x plus y times some polynomial. And of course here, the degree of this polynomial must be n minus 1. We know it from previous tutorials. And last case, x to the power n minus y to the power n is always, for even and odd n, is equal to x minus y times some polynomial of degree n minus 1. Let's repeat how to prove that, this case number 2, why this polynomial x to the power n plus y to the power n is not divisible by x minus y. To prove this, we have to repeat Bezout's theorem. Bezout theorem was explained in our previous tutorials. It states that the polynomial p of x is divisible by a binomial x minus y when p at y is equal to 0. In our case, we had a polynomial x to the power n plus y to the power n. So our polynomial p of x is equal to x to the power n plus y to the power n. And our polynomial at point y is equal to y to the power n plus y to the power n, which is not equal to 0, and that's why we do not have divisibility. And that's all. Next, let's repeat these representations for cases 1, 3, and 4. Let's do it. The first case, x to the power n plus y to the power n is divisible by x plus y when n is odd. When n is odd. So when n is equal to 1, we have x plus y is equal to x plus y. And of course, x plus y is divisible by x plus y. And we have obvious representation, trivial representation. Next, odd number n is equal to n 3. So we have x to the power 3 plus y to the power 3 is equal to x plus y times another polynomial, which is written as x to the power 2. This polynomial has degree 2. The next element will be x to the power 1 and y. So we decreasing the power of x and increasing power of y. Here we had y to the power 0, but we didn't write it. Next, we increasing power of x. We have, decreasing the power of x. We have x to the power 0 or 1. We do not write it. And increasing the power of y. And we put always, first we write minus and then plus. So we have minus and plus. Let's write for next odd number n is equal to 5. We have x to the power 5 plus y to the power 5 is equal to x plus y. Here we have x to the power 4. Next we write x to the power 3y, x to the power 2y squared, x, y to the power 3, and last one is y to the power 4. We write minus, plus, minus, and plus. So it was formulas for n1, 3, and 5. And let's do not write for n equal to 7. This is done along the same way. Next case is divisibility of x to the power n minus y to the power n is divisible by x plus x plus y when n is even. The first even number n is equal to n to the n2. So we have x to the power 2 minus y to the power 2. It can be represented as x plus y times x minus y. So this is divisible by x plus y. Next even number is n 4. So we have x to the power 4 minus y to the power 4. It can be represented as x plus y times another polynomial of degree 3. This is x to the power 3, x squared y, x y squared, y to the power 3. And we write first minus, then plus, then minus. For n, next even number n, which is 6, we write x to the power 6 minus y to the power 6 is equal to x plus y times x to the power 5, x to the power 4y, x to the power 3 y squared, x to the power 2 y to the power 3, x and y to the power 4, and y to the power 5. We write here minus, plus, minus, plus, and minus. And that's all. Next case, when x to the power n minus y to the power n is divisible by x minus y, not plus y, but minus y. In this case, we have divisibility for any n. So for n, 1, we have x minus y is equal to x minus y, and x minus y is divisible by x minus y. Trivial case. Next, when n is equal to 2, we have x squared minus y squared. Again, this is equal to x minus y times x plus y. And this is divisible by x minus y. And we have this representation. Next, n is equal to 3. So we have x to the power 3 minus y to the power 3 is equal to x minus y times polynomial of power 2, x squared, x, y, and y squared. We have to write here plus. By the way, obviously, you know this from previous tutorials. This polynomial can be found when we divide this polynomial by this polynomial. And how to divide polynomials, watch our previous tutorials again. When n is equal to 4, we have x to the power 4 minus y to the power 4 is equal to x minus y and times another polynomial of degree 3, which is written as x to the power 3, x squared y, x, y squared, and y to the power 3. We write plus. We always write plus in this case. And the last case, when n is equal to 5, x to the power 5 minus y to the power 5 is equal to x minus y, and another polynomial of degree 4, x4, x3y, x squared, y squared, x, y cubed, and y to the power 4. And we write always plus. This was everything for this tutorial. Like us and subscribe, and thank you very much for your attention.